The FDTD solver region is used to specify the area or volume that's simulated, simulation time, mesh, and boundary conditions. The structure that we want to simulate here is an infinite array of nanowires with 50 nanometer diameter and a period of 100 nanometers. We'll demonstrate the setup of the simulation region and mesh for this structure, and in the following units, the details of the settings will be covered. To add the solver region, click on the arrow next to the Simulation button and select the Region option from the list. Only one simulation region can be added in each simulation file. Click on the Edit button or use the E keyboard shortcut to open the Edit FDTD simulation window. Under the General tab, the dimension of the solver region can be set to either 2D or 3D. Since I want to represent the nanowires as being infinitely long, I will select 2D, which will take the XY cross-section of the structures. The background index is the refractive index of the background medium, which is 1 by default. The maximum simulation time is set to 1000 femtoseconds, which is typically sufficient for optical wavelength simulations. And the simulation temperature does not need to be set unless I have added an index perturbation material where the refractive index of the material depends on the temperature. Since I do not have any such materials, this setting will be ignored. The Geometry tab is where I can set the position and spans of the simulation region. The X position is 0, and the X span should be set to 100 nanometers to match the period of the array. Using periodic boundary conditions, only one unit cell of the array needs to be included in the simulation region. Set the Y span to 500 nanometers. Since the simulation region is 2D, the Z span cannot be set. However, it's still important to make sure that the Z position of the solver region intersects with the structure that you want to simulate. Under the Mesh Settings tab, I can use the default mesh type, which is Auto Non-Uniform, with Mesh Accuracy 2 to start out with. This will set up a non-uniform graded mesh with a target of 10 mesh points per wavelength. The mesh refinement determines how material interfaces are treated in mesh cells that include two different materials inside the cell. The default conformal variant 0 option works well in most cases, and you can click on the How Do I Choose link here, which will take you to a web page with information on how to choose the mesh refinement option. The time step in the simulation is calculated automatically based on stability criterion, so the time step settings typically don't need to be adjusted. Under the Boundary Conditions tab, the boundary conditions for each side of the simulation region can be set. Set the boundaries in the X direction to be periodic to simulate the periodic array. The Y-min and Y-max boundaries are PML, which are absorbing boundaries. If PML is used, different PML profiles can be set in the PML settings table, and the profiles set the appropriate set of parameters that will optimize the absorption of the PML for different cases. The standard profile is appropriate for simulations where PML is used on all boundaries. Since we have a periodic device which may diffract light to steep angles, choose the steep angle profile. There's a link at the top right which will take you to a page with more information about choosing the PML settings. The Advanced Options tab includes advanced settings such as overriding the simulation bandwidth used for monitors, material fitting and mesh generation, and auto shutoff options which are used to end the simulation early if the fields have fully decayed or if the simulation is unstable. The default settings are typically sufficient. Click OK to accept the settings and check the simulation region in the CAD viewports. You can see the orange box indicating the solver region, where the solid orange region at the Y, min, and max boundaries indicate the PML region, and the boundaries with the blue lines at the sides are the periodic boundaries. Click on the View Simulation Mesh button in the View toolbar to see the mesh that is generated using the Auto Non-Uniform Mesh type with Mesh Accuracy 2. To set a finer mesh around the particle, add a mesh override region from the Simulation drop-down menu. Edit the mesh override region, and set the mesh step size to 5 nanometers in the X and Y directions. The DZ step size will be ignored since the simulation region is 2D. Under the Geometry tab, click on the Based on a Structure option and type in the name of the structure. The Buffer option allows you to specify the mesh override region to extend a certain distance beyond the size of the structure that's specified. Click OK to accept the settings. Click the Recalculate Simulation Mesh button to see the updated fine mesh around the nanoparticle.